This is what we need to think about to try and do this, the derivatives of these things. We have chains of functions here, right? Let's take this one because it's easy to refer to because it's tangent and sine. That is tangent of sine of x, right? So it's kind of like it's a chain of functions here, right? You have an x value, you take the sine of that function, right? And then you take the result of that and you put it in our other function here, tangent, right? So we have three things here. We have our starting number here. Let's just do this. There's our starting number, here's our number in the middle, and here's our number at the end. We want to look at the rate of change of each of those things. If we want to know what dy dx is, here's our y value, here's our x value, here's our little intermediary value, right? What's the intermediate value there? What is it going to be? It's going to be whatever the sine of x is, right? So we want to know this. We want to know, if we want to know the rate of change of y all the way compared to x, right? How do those compare? We have to do it in two steps. We need to look at how does y compare to sine x, and how does sine x compare to that, the values, right? To look at the rate of change between this value right here and this end value, you're going to multiply two rates of change. You're going to multiply this rate of change by this rate of change. You are going to look at the rate of change of, if we're okay, I know that people don't seem to like this d dx notation. If you want to know the derivative of tan of sine of x, that's what we want, right? If we want the derivative of that whole function, we are going to split it into two pieces. Okay? This y over here is tan of sine of x, right? You see these three things here? We are going to say, how does sine x compare to x? What's the derivative of sine x if x was the variable? If x is the variable, what's the derivative of that? It's cos x, right? If I want to compare tan of something, remember, I'm just going to do this as I'm going to ignore what's inside here right now, right? This is the something. The something is that, okay? Tan of something to something. What's the derivative of tan of something? Thank you. It's okay. I realize I got to split it, but that's okay. Tan of something, if something is the variable. Happy face. If happy face is a variable. It's not much of a happy face. What's the derivative of tangent of happy face if happy face is a variable? What was it? Secant squared of happy face. But the thing wasn't happy face. What was it? Wasn't it sine x? Okay. The derivative of something is, first you look at the outside function and just pretend the inside is whatever. It's the variable. So just look at it as happy face, as an empty box or whatever. The derivative of tangent is secant squared of whatever that was. But then we need to say, well, it's not just x in here. If it was just x, I'd be finished. But since it's something other than x, I need to look at the derivative of that something, right? So that's the first part, but I got to multiply it by whatever the derivative of the inside function was, cosine, right? Tangent of something, is it better with the happy face? Make it a sad face because you're sad about this? Yeah. Tangent of happy face, the derivative is secant squared of happy face. But look, this is not a happy face here. Happy face is not the variable. If this said happy face here, I'd be finished, wouldn't I? But it's not the variable, this is x. X is the variable. So I also need the second part of it here. I need to know how happy face relates to x. Happy face dx, right? Whatever that is. The derivative of that happy face prime. Okay? What? I don't know how we got on this. What is that happy face again? It was sine x. What's the derivative of sine x if x is a variable? Cos x. You just need to look at the outside and the inside functions separately in two steps. You look at the outside function as though the inside function is just whatever, right? As though you can't even see what it is. So you look at it as though it's just that, right? It's something. Okay? Tangent of something is secant squared of that something. Then you look at what that inside function is and how it compares. So you're doing it in two stages because the function involves two stages. You're looking at how, I guess I erased it now, but you're looking at how tangent of whatever that is compares to whatever that is, and how whatever that is compares to x. We'll look at this. It is still sine x in the brackets, absolutely. Because that's... Well, we kind of went off the handout there. Let's come back to this page, actually. This is kind of changing it up here because I think the best thing to do here would be to go to this page right here. Okay? This page, which is 35. Go to page 35.